Every time I open a news app or scroll through LinkedIn, I'm hit with some headline that says, studies show or research confirms.
Hmm.
And I think most of us, we just sort of nod and accept it. We treat research like this big black box where smart people put in questions and out comes the absolute truth.
It's a really comforting idea, isn't it?
It is.
That there's just a definitive answer machine somewhere out there.
Exactly. But when you actually peel back the curtain, which is what we're going to do today, you realize that research, well, it isn't a single thing at all. It's this messy, complex, and highly specific engine.
It really is.
We're digging into a really comprehensive session on research methodology by Dr. Ali Akbar. And the biggest takeaway for me wasn't about the statistics or the formulas. It was realizing that how you ask the question completely dictates the answer you get.
That is the absolute crux of it. Dr. Akbar defines research as a systematic and objective investigation. But, those aren't just buzzwords. Systematic means you have a roadmap before you even start driving. And objective means you have to be willing to be wrong.
And that's so hard because usually when we want to know something, we Google it or ask a friend. Right. That's not research.
No, not at all. That's information gathering.
Uh-huh.
Research is distinct because of its structure. It involves design, collection, interpretation, and this is the crucial part: reporting.
So the mission for this deep dive is to take you from that vague curiosity that I wonder why X is happening to understanding the actual machinery of how we prove it.
Exactly. From the very first spark of a question all the way to the final report that lands on a policymaker's desk.
So let's look at that engine. The source material lays out this hierarchy of objectives. It's almost like a ladder of complexity.
Mm-hmm.
At the bottom, you have the simple stuff like assessment or exploration, just figuring out what's there.
You're just mapping the territory. But as you climb that ladder, the stakes get a lot higher. You move into things like evaluation. Is this program even working?
Or comparison, is option A better than option B?
And then right at the very top, you have propagation.
Propagation. It sounds a little agricultural, like we're farming knowledge.
In a way, you are. It's about planting the knowledge so it actually grows.
Yeah.
It's making sure the findings take root in society. But before you can even climb that ladder, you have to decide which lane you're in.
And the source makes a big distinction here between fundamental research and applied research.
Right.
This, to me, felt like the difference between a physicist and an engineer.
That is a perfect analogy. Fundamental research, sometimes it's called basic or pure research, is really knowledge for knowledge's sake.
You're not trying to solve a specific problem.
No, you're just trying to push the boundaries of what humanity knows. You're studying the laws of thermodynamics. You're not trying to build a better refrigerator.
Whereas applied research is the refrigerator.
Exactly. It's often called decisional research.
Yeah.
You have a leaky pipe, a failing school, a drop in sales. You use existing knowledge to fix that specific, immediate problem. It's just practical.
Okay, so whether we're discovering a new particle or fixing a school system, you need a plan. And this is where research design comes in.
Mm-hmm.
The source quotes Fred Kerlinger from, I think, 1986, and he calls it the plan, structure, and strategy. But he adds this one little phrase that I think is the key to this whole deep dive.
What is it?
To control variance.
Oh, yes. Control variance.
Mm-hmm.
It sounds so technical, but what it's really about is trust. It means setting up your study so that if you see a result, you know it's because of the thing you're testing.
And not just random noise or luck.
Precisely. It's the difference between saying, I took this pill and felt better, and we gave this pill to 1,000 people and compared them to 1,000 who took a sugar pill.
Yeah. And John Creswell, another big name in the field, he describes it as the specific procedures. It's basically a checklist, right?
It is. What is the study about? Why are we even doing it? Where? And, critically, how will the data be analyzed?
That last one feels like a trap people fall into. They collect this mountain of data, and then they try to figure out what to do with it.
And that is the cardinal sin of research. If you don't know how you're going to analyze it before you collect it, you're just hoarding information. The design is your contract with reality.
Speaking of contracts, the source breaks down this design phase into 3, let's call them flavors of investigation. And I want to use a concrete example to walk through these because the definitions can get a little abstract.
Yeah.
Let's say. Let's say a company is worried about employee burnout.
Perfect example. Happens all the time in applied research.
Okay, so flavor number 1 is exploratory design.
So in our burnout example, this is the detective phase. The boss knows people are unhappy, maybe turnover is high, but she doesn't know why.
Is it the pay? The hours, the bad coffee.
Exactly. You use exploratory design to just define the problem. The key question is simply, what are the potential issues here?
So this is super unstructured. You aren't handing out a multiple choice survey yet because you don't even know what the options should be.
Right. You're doing interviews, you're doing focus groups, it's qualitative. You're listening to stories to form a hypothesis.
Yeah.
Let's say you do this and you find out everyone keeps mentioning Zoom fatigue and a lack of boundaries.
Okay, so now we have a suspect. That moves us to flavor number 2, descriptive design.
And now we get structured. The goal changes from what's the problem to who is it happening to and how much.
So now you create a survey. You ask specific questions about video calls, energy levels, things like that.
Exactly. You're measuring the frequency. 60% of employees report fatigue after 4 hours of video calls. You aren't explaining why it happens yet. You're just describing the landscape. This gives you the hard numbers.
But then the boss says, okay, but if we cut the video calls, will productivity go down?
And that brings us to the heavyweight champion, causal design.
The hard science part.
This is pure cause and effect. The question is, if we change X, will Y happen? This requires very low flexibility. You might set up an experiment where Team A does video calls and Team B does audio only.
And you measure their output over a month.
Exactly.
So, exploratory finds the variable, descriptive measures the variable, causal tests the variable.
That is the perfect synthesis. Most people try to jump straight to causal without doing the exploratory work, and they just end up solving the wrong problem.
But to do any of that, the interviews, the experiments, you need raw material. You need data.
And the source quotes Robert Yen defining data as information collected from the field. But the big decision here, it really feels like a make versus buy decision. Primary versus secondary data.
It really is a business decision. Primary data it's bespoke. You collect it yourself specifically for your burnout study. It's fresh, it fits your needs perfectly, and you control the quality.
But it's so expensive and it takes forever. You have to hire interviewers, write the questions, find the people.
Right? So maybe you look at secondary data first. This is off the rack. It's, government reports on labor statistics, other academic studies on remote work.
Maybe even internal HR reports from last year.
Exactly. It's cheap and it's fast. It's already there.
But it's historical. It's from the past. And you didn't collect it, so you have no idea if they asked the questions the way you would have asked them.
So you have to weigh the cost against the fit. If you need a custom tailored suit, you buy primary. If you just need a shirt for the gym, secondary is probably fine.
That's a great way to put it.
Now, there is this physical reality to research. You can't interview every single worker in the world. So unless you're the Census Bureau, you have to sample.
Sampling is the art of compromise. We're constrained by time, money, access. So we take a subset of the population. But how you pick that subset is what determines if your results are trash or treasure.
The source splits this into 2 big pillars, probability and non-probability. And I feel like this is where news headlines so often mislead us.
100%. Probability sampling is the absolute gold standard for generalization. It means every single member of the population has a known, random chance of being picked.
This is the scientific poll.
Yes. And because it's random, math lets us say this sample represents the whole group. If you do it right, 1,000 people can tell you what 300 million people think. It's amazing.
But then there's non-probability sampling. That's not random. It's based on convenience or some other criteria. Like if I just stand outside my office and ask the first 10 people I see about burnout, that's convenience sampling.
Right. And you can't then go on the news and say, America's burnt out.
No.
You can only say, these 10 guys standing outside my office are burnt out.
So why do we even use it? It sounds so much worse.
It's not bad. It's just for a totally different purpose. If you're doing that exploratory work we talked about, finding out why people are burnt out, you don't necessarily want random people.
Oh, right.
You might want experts. You might want to specifically talk to HR directors. You purposefully select them because they have the information you need.
So context is everything. We shouldn't dismiss these studies. We just need to know they apply to a specific group, not the whole world. Okay, so we've designed our study, we've sampled our population, we've got the data. Now we have to actually make sense of it. Analysis.
This is where the road forks again. You have quantitative the numbers and qualitative the stories.
Let's hit the numbers first. The source lists the branches of statistics, but let's just decode what they actually do. You have descriptive stats, mean, median, mode. That's just the batting average.
It just summarizes the pile.
Yeah.
Then you have inferential stats. This is the judge. You use tools like t-tests to answer one simple question. Is this difference real, or did we just get lucky?
Then association, that's correlation. Do these two things move together? Like, does coffee consumption go up when sleep goes down?
And finally, prediction. That's regression. Can I use what I know about X to predict what Y is going to be next year?
That all feels pretty familiar to most people, but the qualitative section, I think people really underestimate this. They think it's just reading the notes and catching a vibe.
It's such a common misconception. The expert in our source material emphasizes that qualitative analysis is rigorous. It involves coding. It's systematic. You're not just reading. You are dissecting the text.
The source lists some fascinating methods here. Thematic analysis, looking for patterns across the whole data set, and content analysis, which is almost like just counting words in a way.
But then it gets much deeper. Phenomenology. This one is my favorite. It's not about counting at all. It's about trying to describe the essence of a lived experience.
The source gives the example of the experience of grief.
Right. You aren't trying to measure how much someone grieved or for how long. You're trying to describe the universal structure of what grief actually feels like for a human being.
Wow. That's powerful. It really captures the things numbers miss.
It does. And then there's discourse analysis, analyzing how language itself constructs power. Like you could analyze political speeches to see who's really in charge of the narrative.
And grounded theory. That's where you're so open-minded you don't even start with a hypothesis.
You let the theory build itself up from the ground, strictly from the data you find. It's incredibly difficult to do well, but it leads to brand new ideas.
So we have all these amazing tools, but how do we know if we can trust the final result? This brings us to the litmus test concepts: validity and reliability. I used to think they were synonyms.
Most people do, but they are very distinct. Reliability is just consistency. If I step on a scale 5 times in a row, does it give me the same number all 5 times?
Okay. And validity is accuracy. Is that number actually my real weight?
Exactly. You can have a scale that is perfectly reliable, says 150 pounds every single time, but if you're actually 180 pounds, that scale is reliable but completely invalid.
It's consistently wrong.
It's consistently wrong, and that's a scary concept for research. You can have a perfectly repeatable study that is just measuring the wrong thing entirely.
Which is why the design matters so much from the very beginning.
It all comes back to the design.
Now, let's suppose we succeed. We have a valid, reliable, insightful study. We're done, right? We publish the paper and go home.
You would think so. But the source material makes a huge point here. It says the cycle is not complete without dissemination. And this is where academia, I think, often fails.
Oh, it does. Research fails if it stays in a drawer.
Dissemination is the planned process of sharing findings, and the key word there is planned. You can't just copy-paste the same report and send it to everyone.
It's the marketing side of science. You have to know your audience.
Absolutely. If you're talking to other academics, you give them the theory, the methodology, the p-values. They want to check your work. They want to see inside the engine.
But policymakers, they couldn't care less about your p-value.
No. They want the bottom line. Cost effectiveness. They need a one-page executive summary or policy brief. They need to know, what do I sign and how much is this going to cost?
And then you have the practitioners or, say, faith-based organization leaders, the people who are actually doing the work on the ground.
For them, the source suggests things like town halls or community newsletters.
Yeah.
You got to focus on community impact and ethical alignment. If you hand a community leader a 50-page, dense academic paper, you haven't shared knowledge.
You've just handed them a paperweight.
That's all it is.
This leads directly to the barriers to knowledge. We do all this work, but the message just doesn't get through. Why?
There are 3 big walls. First, jargon. Using a complex term like epidemiological variance when you could just say health difference, you alienate the very people you're trying to help.
The second is access.
The dreaded paywall. If the solution to a community problem is locked behind a $40 journal download fee, a local health department or a nonprofit can't use it.
And the third one really stood out to me, cultural mismatch.
This is so critical. The source gives a very specific example involving faith-based organizations. Imagine you have great data on reproductive health, but you present it in a way that completely ignores the values or the language of a conservative religious community.
You're speaking a different language.
Exactly. They won't listen. It doesn't matter how valid your data is. If you don't frame the dissemination in a way that aligns with their cultural context, the delivery fails. And if the delivery fails, the knowledge just dies right there.
It's a great reminder that facts really don't speak for themselves. They have to be translated.
Precisely. If knowledge isn't understood and applied, it's just potential energy. It hasn't done any work yet.
So let's look at the whole picture then. We've gone from defining a problem, choosing a design, whether that's exploring a new issue or running a really strict experiment, collecting the right data, analyzing it with rigor, and finally getting it into the hands of people who can actually use it.
It turns research, from this scary academic word, into a tool for social change. It's the bridge between not knowing and doing better.
I want to leave you with a final thought on that barrier to knowledge. We live in an information age, but I really wonder how much actual knowledge we have access to.
That is the provocative question, isn't it?
If a study is conducted with perfect methodology, but it's hidden behind jargon or a university login, does it truly exist for the public? The sources we looked at suggest that without proper dissemination, the research cycle is broken.
It's incomplete.
So next time you see a headline, maybe ask yourself, am I getting the policy brief version? Am I seeing the raw data? And who translated this for me?
Always question how we know what we know.
Thanks for diving in with us. We'll see you next time.